Hi, I'm Percival Messina. I work at IBM Research in Brazil. And as we mentioned earlier during our panel, we believe that blockchain can be used in several supply chain scenarios. And this presentation explores how blockchain can be used in a supply chain scenario applied to agribusiness, where we can track grain quality using blockchain smart contracts. So I was not sure if I started talking about technology or I started describing the problem, so I decided first to describe what's the problem we're trying to solve, so then we can I can say a little bit about what's our solution for that problem. So several supply chain scenarios, like in agribusiness, we have different business partners that are part of the process, and they need to share information, and they have conflict of interests on how they share that information. For instance, Brazil is a huge export of what we say are commodities, like exporting chicken, exporting coffee, exporting soybeans. Most of our exports are from those primary products. And one of the main issues we have is how can we assure the exact classification of the products that are being exported, because depending on the classification of the product, the price will vary a lot. Also, all those products, they deteriorate during the chain. So once you have a good crop 3 months ago doesn't mean you have a good crop today. So how can we use blockchain so we could integrate the farmers, the warehouses, the trading companies, the port authorities, so they could share information and do their transactions in a fair way? So what do we have today? What we have today is that we basically have silhouette information in different systems, and the information is most of the times they are not very accurate, which means that you might have coffee classification in a warehouse that differs from the coffee classification you have for an exporter. So how we can make sure that those transactions would share the same information? Nowadays, those systems, they talk together using different APIs. And one of the main problems we have is that the rules are not the same for the system. So even if we share that among the partners, doesn't mean that everyone is doing exactly the same rules. There are some standards, export standards, but those are things that are executed only once. It doesn't mean that all the transactions follow those processes. So our approach here is to create a permissioned blockchain, blockchain which is composed with nodes on a private network that would share the same rules through the use of standard smart contracts. So basically our work was created on top of Hyperledger Fabric. Hyperledger Fabric is a project from Linux Foundation. There is more than 100 companies and universities that collaborate on this project. And it's a project for a permissioned blockchain. So which means that there is a membership service that determines who can run nodes in this network. So only the people who are on this membership services directory are able to submit transactions to this network. Those transactions are executed basically on smart contracts that are programmable in Docker, in a secure virtual machine, where they can execute arbitrary code inside it. And those smart contracts, they would be able to create transactions which values would be stored in a centralized, a decentralized database, which is we call word state. This word state would be replicated in each of those nodes, and one of the basic characteristics is every information in this word state has a key, and it can store arbitrary data there. So smart contracts have the logic, and they persist that logic in the word state, and every time the smart contracts reach consensus through some consensus protocol like PBFT or Apache Kafka with some middleware that's also used to implement the consensus mechanism, a new transaction would be stored in this cloud of transactions. That's the blockchain. So how do you basically create those permissioned networks? Well, Hyperledger is an open source software, which means everyone can download it and run their nodes in each of the, in a single computer, in a distributed network, whatever they want. And as soon as these nodes are connected to a same membership services, they can operate together. Of course, we usually have some kind of authority, governance authority that determines who can enter those membership services. But besides running those, what we call ad hoc networks, we can also have create what we call blockchain as a service, which basically you choose some location worldwide where you can run your nodes inside of an IBM network, cloud network. So what we basically done here and we presented in this paper is that we chose some of those processes of the supply chain, of the agribusiness supply chain, and we implemented them using smart contracts on a Hyperledger blockchain. So we basically chose a couple of warehouses, farmers, and trading companies, and we used IoT devices to capture some quality assurance data about the grains that were being tracked to this network. So I'd like to show a little bit of how the process really works. So a farmer starts producing something, like this is soybeans, right? He gets a truck load full of soybeans and sends that soybeans to a warehouse facility where we have those big crayons that collect samples, and those samples go through some tubes to a lab where we're going to be analyzed by some LIMS, Laboratory Information System. So after the samples are collected, we have technicians that do some manual work, like determining if the grain is transgenic or non-transgenic, if the grain is organic. So in order for you to get that information, you need to run some lab procedures, and you need to get the samples and put those samples in some equipment, and those equipment is really connected to a smart contract that will store the information about the sample. So whenever we receive a sample, the sample is identified and the sample information is stored on blockchain. So this is basically a procedure to determine if the soybean is organic or not. So it goes through some chemical reaction that will go to a special equipment that is connected through blockchain through a smart contract. So after we determine the grain quality and the grain classification, there is the grain monitoring. So we also have some equipment like silo monitoring equipment that goes through while the grain is stored in a warehouse. We basically get information if temperature is kept correctly to make sure that the grain quality is not deteriorating. Of course, when the grain leaves the silo, we still need to run the same tests again to make sure that the quality of the grains are preserved. Then afterwards, the grains, they leave the warehouse, they go inside containers, they also go in bulk, in truck bulks through the port. So we have some trading that bought this specific grain and want to make sure that it is exporting the right grain that the buyer in US or in China has decided to acquire. So we run a set of sample tests again. This is a laboratory in the port that will basically try to make sure that the grains that are stored in that container has exactly the same quality that was determined by the buyer of the grain abroad. There are some specific tests for specific grains, like for coffee. It involves some manual tests where we have a tester that will prove the coffee, and based on the certified tester will basically do the classification based on some things we can capture using IoT, like smell and taste. So we basically need to trust his opinion about the coffee quality. And then as the last part of the process, the container goes inside a vessel and it goes for exportation. So what did we exactly do? We basically got some information about some processes. So this is like a quality assurance table that was used in the warehouses. So we basically got that information and coded that into a smart contract. So we would make sure that the quality and the price would be determined exactly the same way as the current rules work, but that would be done basically using information captured from IoT devices for soybean export. So basically, this is an example of the blockchain we created. It's just a set of transactions from different warehouses where we have the information about the grains stored inside the blockchain, and we are able to get a sample and we are able to get the history of that sample. So how was the quality when it arrived the warehouse? How was the quality when it left the warehouse? How was the quality when it arrived into the port? So we are basically to do the traceability of the grains using blockchain. So for grains, it's a kind of complicated, right? Because it's hard to have an asset and make sure it's exactly the same asset, because the asset is changed all the time. It's different from a diamond, right? If you have a diamond and you engrave the diamond using the laser, once you have the correct classification, you don't expect that diamond to change. So we basically need to do the classification only once. But for tracking grains, it's much more complex. You need all the time to do tests to make sure if the grains are keeping the same quality or not. And there are the conflicts of interests in the chain because the farmers always say that the grain has a better quality than the trader says. So how those guys could have some fair trading rules encoded into those smart contracts. We also had to integrate with back-end systems. So we basically developed a REST API which has basically some authentication, no authentication mechanism that allows that the information of blockchain to be integrated with back-end systems, right? Because, for instance, the trading companies, they needed to be able to query information from their grain's quality inside their existing back-end systems. So we basically created this REST API that integrates with their back-end systems. A few conclusions we have from this work. Trusted information among a chain requires standard practices. So in order for us to implement a business network, we needed to have common rules that would be shared on the smart contracts, and that is more easy to say than to do, because different companies have different classification rules, and you need to get to a standard way of which rules would be applied into the smart contracts. IoT integration helps getting the right information inside blockchain, but most of the time we found that's not enough. That's why we added an extra step that was recording for every transaction a participant in the network that is responsible for that information. So storing information in blockchain is useless if the information is wrong, and it's hard to determine what information is right, so conflicts would still exist. So the way we found to deal with that is that by every transaction has a participant that's responsible for a transaction. It might be a lab technician, it might be a truck operator. So we don't have an anonymous transaction on this permissioned blockchain. Every transaction that is stored there has the identity of someone who is responsible for that information. And that identity is created using some biometrical tool like finger recognition, or also a simple password in case it's not possible to do any kind of biometric. But all the transactions are backed by some person who is responsible for that information. So if a conflict exists or a wrong information is inputted into the system, we are able to trace back who was the person who was responsible for storing that transaction on blockchain. We also found that sometimes the participants don't want to share information. They don't want all the transactions to be public, even on a private network. So the Hyperledger project has the concept of channels that are like having private blockchains inside a blockchain. So we can have a transaction that's signed by only the people who are involved on that transaction, and that transaction is not visible through the whole network, but only between the nodes that are executing this transaction, so that it allows some greater level of privacy between the participants of the network. We also found in that auditing process are some complicated things that could be executed by third parties, like inspector companies using query mechanisms that are available through the platform. We also found that this kind of application we created in Brazil is very similar to other efforts that are being done worldwide on food safety and also on supply chain. And last but not least, I think the hardest lesson we learned is that although blockchain technology allows us to do many interesting things, creating consortium and governance in those provisioned networks, it's something really hard to do. And standardizing those processes sometimes involves different countries, and there is no simple answers on what kind of standards should be applied on each case. Thanks for your time. That's my contacts in case you want to know.
This feels like one of those classic questions of why blockchain here, because it's permissioned and private. I just feel like it could be a MySQL database.
Yeah, there was that discussion, I think, earlier in the panel, right? Every time you have disputes, right? We have dispute between the players, right? And we want to make sure that all the players follow the same rules, right? When I'm buying coffee from some warehouse, there are warehouses all around the country. So how can I know that specific warehouse is following the same rule as the other warehouses? So blockchain smart contracts work like a standardization process that makes sure that all the warehouses in the network follow the same procedures. So it's not a problem of only sharing data, right? It's mostly basically a problem of making sure that everyone in the network follow the same standard
But the same
procedures.
code that wrote the smart contract would just sit on the same web server that everybody's hitting behind the same set of APIs, right? And then it could just be centralized.
Well, if there was a standard API and everyone already followed that API, we wouldn't have the consistency problems, right? The existing scenario that we have before like that is we already have those APIs, and the basically problem is that those APIs don't follow the same rules, right?
No, but you want to build a whole new system, so why don't you just build a new system on a MySQL database instead of a blockchain? That's my point. Like you said, the hardest thing was the governance and the getting everybody to coordinate. You did all of that work, but you put blockchain behind it. If you're going to do all that work, you could have just put a MySQL database behind it. That's my point.
So I think, yeah, I think that the answer is that
just don't want to trust a central database, and you want to make it decentralized. That's the only answer I can.
But it's not decentralized, is it? That's my point. It's centralized.
Well, every node has its own copy of the data. So, and the private channels, I mean, when you do that, the commercialization of the grants, for instance, you don't do, the same grant can be sold at different rates for different tradings, right? There is some privacy issues here. You don't want all the data to be public to everyone.
You can have permissions behind a web server. You know what I mean? Like it's all just
I think the answer is if someone attacks the web server,
all the information is gone, and with this blockchain, I guess the information is distributed, and then there's no single point of failure. That's the answer that I see. That's, I mean, I don't know.
And who should I trust, right? If I have a single server.
well, now everyone has to trust IBM.
Why single server? You have distribution. You may have a distributed architecture with database.
But who owns the database? Who owns that? Each node is owned by a different, you might have different trading companies. You don't want Cardio and Bungie to share the same data. They will never agree with that. Everyone wants to have their own private copy. We are competitors.
But they are sharing, and they have to trust that. So it's the same if you have a database where you are restricting your. Yes. Just, I think most probably if you would today you have to put that in a very small proof of concept. I guess when you would scale, most probably at the level of scaling, you would show the interest. But on a very small scale where we could replicate that with a database on not too many actors, it's not interesting. But I guess if you're putting 10,000 of users with different things, then it may be helping, because then you will have this kind of thing. But the mere fact that you say, okay, inside the blockchain, we had to use the blocks specific to Fabric, to Hyperledger, you were creating a restriction that you could have put also inside an access control inside your database. You have customized something which you can also replicate somewhere else. I think we must find for this kind of thing more compelling argument than just saying it's a replication. We have solutions of replication. You have worked for years on replication.
So I have a question actually.
Yeah.
So, your slide hinted that you're bringing sites online at places like Ashburn, Singapore. The question I have is, how large is your database, the blockchain database right now? And what do you need to do to bring these new sites online? Do you have to replicate the entire data set? What exactly happens?
Well, whenever you create a new node on the network, this node will basically sync with the other existing nodes. So basically, when you bring a new partner online, it will before it go online, it will spend some time catching up with all the existing log of transactions, right? So basically, you can add new partners to this network as the network evolves. And this specific case involves only a few agriculture players, but we have other business networks like the food safety here in the US that involves very large companies like Nestle, like Walmart, and there are so many different companies sharing food safety information on that network, and most of those things are private, right? They are not being seen by the competitors. So it can go to the word state database can grow. It's based on CouchDB, which is a NoSQL database that could scale very well to terabytes of information if needed.
Why don't I just DB2 with that?
There is some work, yeah. We have here in our lab a version, a private version running on DB2, on DashDB with DB2 running inside a Docker container. It's just not public.
Any other questions?
Regarding channels, have you seen any practical limits on how many subledgers Fabric can support based on current technologies? In your agriculture example, right? You have 1,000 farmers and 1,000 silo operators and so on, right? They all need to transact in privately, right?
They may choose to transact in private or may choose to transact.
Yeah.
We have not conducted a study in the number of channels, but we have conducted several performance studies. So we can have a sub-second latency and 350,000 transactions per second on a network that's hosted on a cloud, and we have a paper published about those how those numbers work.
But you haven't tested it with 100,000 channels on one private network?
No, those numbers are created using public channels, not using private channels.
All right, let's thank the speaker.